So in this section, we're going to be solving those quadratics again, but we're going to be using basically the steps in which we solved back in Unit 1. So when we talked about when we would move things using adding and subtracting, and we would use multiplying and dividing. So that is what we're going to use in order to solve this. Now, that is because in all of these problems, we are going to only have an x squared. So if you want to write yourself a note, only use solving by square roots when you just have x squared. If you have anything like a 6x, a 2x, you're in that standard form, you're not going to be able to use this method. So let's start off by looking at this first one. X squared equals 49. Now, if I look at this, I have to get x alone. So I have to get rid of that squared. So in order to get rid of a squared, the opposite of that is a square root. So I'm going to take the square root on both sides of my equation. Now, this is going to just cancel out that squared at the top. We need to write ourselves another little note. So on the side, make yourself a little note. Whenever you square root on both sides, you must put plus or minus. So what this means is that whatever we get for the square root of 49, it's going to be positive or negative, whatever that answer is. Now, if we type in the square root of 49 to our calculator, we would get 7. So what this is saying is if I were to plug this back in, positive 7 would give us 49 and negative 7 would give us 49. So if I were to check this and I plug in positive 7 squared, it does equal 49. Same thing, negative 7 squared means negative 7 times negative 7, that would also equal positive 49. So that's why this point over here of putting that plus and minus is super important. Whenever you take a square root on both sides of your equation, you are going to have to put a plus or minus symbol. Alrighty, let's try some of these examples. We have to get rid of that squared, so we are going to take the square root on both sides. And if I do that, it's going to cancel out that squared. And I took the square root on both sides of my equation, so I have to put the plus or minus symbol. And then if I type into my calculator square root of 169, it's going to give me 13. So that means if I were to plug that back in, 13 squared would give me 169. And negative 13 squared would also give me 169. All right, let's try the next one. If I take the square root on both sides to get rid of that squared, it's going to cancel that out. And x equals, I took the square root on both sides, so I'm going to have to put plus or minus. And then if I go to type in square root of negative 16, your calculator will probably say something that says non-real answer. So what this means is that it's not possible to take the square root of a negative. So if you want to write yourself a note, not possible, to square root a negative. So whenever you square root a negative, it's going to say this, because no matter what you do, if you do a positive squared, it's going to give you a positive. Or if you do a negative squared, it's also going to give you a positive. It's never possible to square something and get a negative answer. So we would say no real solution. Whenever we have the square root of a negative, our answer is no real solution. Alrighty, let's look at this next example. So we have a little extra step. We have a 7 out front. So if you remember, we talked about order of operations. Whenever we're solving, we're doing PEMDAS backwards. So we're looking at getting rid of adding and subtracting. Then we're looking at getting rid of multiplying and dividing. Then, we never talked about this before, but we're doing it now. We're getting rid of those exponents, that's squared. And then we'll deal with anything inside of parentheses. So this is super helpful in this section. So looking at this problem, I do not have any adding or subtracting, but I do have multiplying. So that 7 I'm going to get rid of because it's multiplied. I'm going to divide by 7 before I'm able to get rid of that squared. So when I type that in my calculator, I get x squared equals 16. Now I'm able to do my exponents. So I did all of these steps and I'm now looking at exponents. So I can take the square root on both sides, which will get rid of that squared for me. And since I took the square root on both sides, I have to put plus or minus. And when I type in the square root of 16 into my calculator, I get 4. Alrighty, let's look at this next one. Remember, each time we're going to be using SADMEP PEMDAS backwards. So I'm going to write that on top of each example so I can use it and cross stuff off. So I like to look for adding and subtracting. I don't have those. I don't have anything dividing, but I do have 3 times x squared. So I'm going to divide by that negative 3 to get rid of it, leaving me with x squared equals, and negative 24 divided by negative 3 is going to give me a positive 8. Now I'm able to deal with my exponents, so I'm going to take the square root on both sides, and it's going to cross out that x squared, or the s squared. And since I took this square root on both sides, I need that plus or minus symbol. And if I type in square root of 8 into my calculator, I get a decimal. Now, we just talked about in the last section that we do not want any of our answers to be decimals. Unless we're working with a word problem, we really want to just simplify this radical. So let's use the skills from last section and see if I can break down the square root of 8. So I know that 8 is 4 times 2, and 4 can break down to 2 times 2. So I have a pair of 2's and a leftover 2. So I would have x equals that plus or minus. My pair goes out front, and my leftover goes underneath the radical. So I have 2 square root of 2. Alrighty, let's look at the next one. I do not have adding or subtracting yet. I do have something that's 5 times, so I'm going to get rid of it by dividing by 5. So if I do that on both sides, this is going to cancel, leaving me with x squared. And 125 divided by 5 is going to leave me with 25. So I did my multiplying. Now I'm able to do exponents. So in order to get rid of that exponent, I'm going to take the square root on both sides, canceling out that squared, and leaving me with an x equals, and since I took the square root on both sides, I need the plus or minus. And if I put square root of 25 into my calculator, it's going to be 5. Alrighty, let's look at this next example. Again, we're doing that same SADMEP process, and we're adding in all those different elements now, slowly but surely. So it looks like on this first one, I have subtracting. I have my very first thing, subtracting. So I'm going to get rid of that first by adding 5 on both sides. So that's going to leave me with 3x squared equals 27. So I did my subtracting. I don't have anything that was added. I don't have anything that was dividing, but I do have something that's multiplying. So 3 times x, I'm going to get rid of it by dividing by 3, leaving me with x squared equals 9. Now that I got rid of that multiplying, I'm going to get rid of my exponents by square rooting on both sides. Getting rid of that squared, so I would have x equals, and I took the square root on both sides, so I need a plus or minus symbol. And the square root of 9 is 3. Alrighty, let's try some more examples. We're doing the same process again. We need to do that SADMET process. Okay, so it looks like I already have something subtracting, so I'm going to get rid of that by adding 19 on both sides. So that's going to leave me with negative 5x squared equals, and I do 144 plus 19, and that's going to give me 163. Then it looks like I have to divide by negative 5 on both sides because I did all of these and I need to get rid of that multiplying. So if I divide by a negative 5, I take 163 divided by negative 5, and it's going to give me negative 32.6. Now I know we talked about not having decimals, but let's look at what happens. If you see, the next step we're going to have to do is get rid of that exponent. And if I do that and I square root on both sides, I see that I have square root of a negative number. If I were to type that into my calculator, we know that we are not able to do the square root of a negative. So I would say this is no real solution because we cannot take the square root of a negative number. Alrighty, let's look at this next example. I see a little bit of a tricky situation on this one because we have x squareds on both sides of our equation. So what I want to do before I do SADMEP at all, I want to get those x squareds on the same side of my equation. So I'm going to move this positive 4x squared over to the other side by subtracting 4x squared. Because 4x squared minus 4x squared will become 0, leaving me with 30. And then on this right side, I'm able to combine these like terms. 7x squared minus 4x squared would give me 3x squared. So now I'm able to do my SADMET process, and I see I don't have any adding or subtracting. Nothing is being divided, but I do have something being multiplied 3 times x squared. So I'm going to divide by 3, leaving me with x squared equals 10. Now that I got there, I'm able to get rid of my exponents now. So I'm going to square root on both sides. Since I square rooted on both sides, I'm going to need to add that plus or minus symbol. And if I type square root of 10 into my calculator, I get a decimal. So what I want to do is I want to break down the square root of 10 and see if I'm able to simplify it at all. So 10 breaks down to 5 times 2, and then it looks like it can't simplify any further. So we don't have any pairs, so this is going to stay plus or minus the square root of 10. Alrighty, last example, we're doing that same process again with that SADMEP that we've been talking about. And we need to start off by looking at for adding and subtracting. Now, I see subtracting a minus 10, and I see adding that plus 7. But if you notice in our order of operations, that plus 7 is inside parentheses. And we know that we have to do parentheses dead last. So I'm going to leave that plus 7 alone, and I'm going to get rid of that minus 10. So I'm going to add 10 on both sides, leaving me with 5. X plus 7 squared equals 125. So I did these, and now I need to look for, is there anything being divided? No. Is there anything that's multiplying right now? Yes. This 5 is multiplying times that parentheses. So I'm going to get rid of it by dividing by 5 on both sides. So that would give me x plus 7 squared equals 25. So I got rid of my multiplying. Now I need to get rid of those exponents. So I'm going to take the square root on both sides, which gets rid of that squared. And it's going to leave me with an x plus 7. And I'm going to take those parentheses out because that's the only thing we have left is that stuff that was inside the parentheses. And I know since I took the square root on both sides, I'm going to need to add that plus or minus symbol. And the square root of 25 is 5. Now, this is a little tricky because if you read this situation that we're left with, we have x plus 7 equals a positive 5 and x plus 7 equals a negative 5. So when you get this and you have to continue to solve, what I like to do is break this up into two situations. Exactly what I just read. X plus 7 equals a positive 5 and x plus 7 equals a negative 5. So I'm going to solve each of these separately. On this first one, I'm going to subtract 7, so that's going to give me x equals negative 2. So we have negative 2 as one of our answers. And then on this next one, if I take minus 7 on both sides, it's going to give me x equals negative 12. So we have two totally different answers. Alrighty, on this last one, we're still doing that same process again and again. And we're going to look for, in this first one, do I have anything being subtracted? I do, but it's inside parentheses, so I'm not going to touch that minus 4. I do have something being added, so I'm going to subtract 6 on both sides, giving me x plus 4 squared equals 4. Then I want to look, do I have anything being divided? No. Do I have anything being multiplied? No. I do have exponents, so I'm going to get rid of that by square rooting on both sides, getting rid of that squared, and just leaving me with an x plus 4. Since I took the square root on both sides, I need a plus or minus symbol. And if I type in square root of 4 into my calculator, I get 2. Now, this again is where we have two different situations that are happening. It says x plus 4 equals positive 2 and negative 2. So I'm going to split these up. X plus 4 equals positive 2 and x plus 4 equals negative 2. So I'm going to solve each of these separately. I'm going to subtract 4 over here. So my first answer is going to be negative 2. On my second equation, I'm going to subtract 4 also, but this is going to give me a negative 6. Alrighty, last example. Let's do our order of operations again backwards. So I'm looking, do I have anything being subtracted? No. Do I have anything being added? Yes. So I'm going to subtract that 13 because I don't want to move that plus 4 because it's inside parentheses. So that would give me negative 3, x plus 4 squared equals, and then if I do negative 107 minus 13, it's going to leave me with negative 120. Okay, so I did my adding. I don't have anything being divided. I do have this 3 times my parentheses. So I'm going to divide by that negative 3 on both sides. And that's going to leave me with x plus 4 squared equals 40. So I did my multiplying. Now I need to get rid of those exponents. So I have to square root on both sides to get rid of that squared, leaving me with an x plus 4 equals, I took the square root on both sides, so I need a plus or minus. And if I type square root of 40 into my calculator, I get a decimal. So I want to try to break down this 40 as much as I can. Well, I know that would be 4 times 10. This would be 2 times 2, and this would be 2 times 5. So I broke all these numbers down, and it looks like that's as far as I possibly can go. So I have a pair of 2's, and a leftover 5 and a leftover 2. So that means that I would have x plus 4 equals plus or minus 2 square root, and the 5 and 2 go inside the parentheses, and I'm going to multiply them. So that would give me 10. Now, we have x plus 4 equal to this crazy radical. So if I subtract 4 on both sides, here's how I want you to write your answer. You're going to put that negative 4 out front, plus or minus that crazy radical. So whenever you're doing one like this, your crazy radical is going to go second. And you're just going to leave your answer like that. I know it looks crazy, but it's okay.